Hello, GeoData students. So we're finishing up Investigation 1 today. We're going to do Lessons 5 and 6, and we're starting on page 57 in the workbook. So as a quick reminder, we talked about the mid-segment of a triangle in the previous unit, and the mid-segment connects the midpoints of two sides of the triangle, and it forms some pretty interesting relationships. So the mid-segment is parallel to the third side. So if we have a triangle here, and if this is the mid-segment, the cool thing is this mid-segment is parallel to that third side, okay? That mid-segment, also D, is the midpoint. E is the midpoint of AC. D is the midpoint of AB, okay? And that means that this length AD is going to be exactly the same as DB. Okay, they're going to be congruent because they're each half of the total length. The same thing on the other side. AE is half of the total side, and EC is the other half, so they're also congruent. And then the other interesting thing is that since this piece is half of the total, this piece is half of the total, that means this side is half the length of this side, okay? So DE, the length DE, is also going to be half the length of BC. So those are some very interesting things about mid-segments. What we're going to talk about today is what if we drew a line that cut through a triangle and it was parallel, but it didn't cut through exactly at the midpoints. It didn't cut through halfway through, but at some other point in the triangle. So that's what we're talking about today. And it's called the side-splitting theorem. We're going to go to page 63, and we're going to talk about the side-splitting theorem. Okay, so what we have here is a triangle, ABC, and we have a line, DE, that cuts through it. It does not cut the sides in half, but we do know that this line is parallel to that third side of the triangle, okay? So the side-splitting conjecture says that it's going to divide these sides proportionally, okay? That means if we set up a proportion with fractions, with ratios, the proportions or the ratios on one side will be equal to the proportions or the ratios on the other side. What that means with these numbers then, we're told that AB in total would be 16 units long, and this line cuts it into two parts, 6 and 10. AC, we don't know how long it is. We know this part is 8. We do not know how long this part is, okay? But we know X and 8 have to have the same proportion as 6 and 10. So we can write a proportion where you compare the parts. So we can compare 6 compared to 10, right? That would be like the top part compared to the bottom part is going to be equal to the same proportion on the other side. The top part is X, the bottom part is 8. And now all we have to do is solve that proportion. And you may recall that we can do cross multiplication. You can multiply both sides times 8, and you can multiply both sides times 10, and then what you end up with is 8 times 6 equals 10 times X. 8 times 6 is 48. Divide by 10, and X is 4.8. Now let's see if that makes sense. Look at the numbers. So this is much less than this. It's a little more than half, right? Half would be 5. This is more than half. So look at this side. Well, half of 8 would be 4. This is a little more than 4, right? So the numbers make sense, and this is less than that. 8 is less than 10. It looks good. Okay, so we did that. Let's look at the bottom triangle. It's a similar situation. You have a big triangle and you have this line cutting through it, and they're telling us it's parallel. That has to be true or we can't do anything. So we know those are parallel, which means the proportions have to work. All right, now they want to know how long this whole side is here. So let's think about what we know and what we can figure out. All right, well, we know that this side and this side are going to have the same proportion as this whole side and this whole side. So that might be helpful. Okay, so we could compare the 6 to the 8. Or we can even do this. We could compare this side to this side, 6 to 18. And then we could compare that to 8 to that whole side, right? So that whole length is going to be x. What if we did it like that? Okay. Small triangle side to big triangle side. Small triangle side to big triangle side. 6 over 18 equals 8 over x. If we do that and cross multiply, 6x equals 8 times 18, x is 24. But that doesn't really help us. We don't want that side. We want the third side. That's going to be our friend Mr. Pythagoras. Pythagorean theorem. You may recall a squared plus b squared equals c squared. This is a right angle. So we have one leg. What we're looking for is the hypotenuse. That's the part we're missing. So this is like the A, this is like the B, and that's the C. So 24 squared plus 18 squared equals our answer squared. Okay? So 24 squared is 576. You can just grab a calculator. 18 squared is 324. If you add those together, they add up to a nice even 900, which is fantastic because we need to take the square root. We don't want 900 equals c squared, we want c. So we square root both sides, and c is 30. Okay? So that is how we can use the side-splitting theorem as well as the Pythagorean theorem to solve that problem. All right, let's go on to page 65. I'll give you another example. On page 65 at the top, we have a big triangle with a line that they're telling us is parallel. Okay, so you always need to know that. They're telling us BX is 4, so BX is 4. BA, that's the whole side, is 5. And they're telling us BY is 6, and they want to know what this whole side is. Okay, so we're going to compare the part to the whole on both sides. So we're going to compare 4 to, what's the total? 5. That means we have to do the same thing with the other side. The corresponding part to the 4 would be the 6 compared to the total. That's what we don't know. Let's call that, I don't know, A. All right? And then we can solve by multiply both sides times A, multiply both sides times 5, and you get 5 times 6 equals 4 times A. 30 equals 4A, and if you divide by 4, A is 7.5. Does that make sense? Let's take a look. Doesn't look like it from this diagram, but that's why they say that. Be careful, all right? They purposely make the diagrams not fit the numbers properly because they want you to use math and not just use your eyeballs, okay? So this number is bigger than this number, so we need this number to be bigger than this number, and it is. Okay, Now they're switching up the numbers. They're using the same diagram, but they're changing the numbers. So I'll change colors. What if BX is 9, BA is 15, BY is 15, and we want to know, now we want to know what this piece down here is. So be careful, okay? We have a part and a whole and a part and a part, okay? So we can't compare them. What if we figure out what this piece is, okay? If the whole thing is 15 and this part is 9, this has to be 15 minus 9, or 6, right? So we know this piece has to be 6. Now we can write a proportion, part to part, part to part, okay? So I'm going to compare the 6 to the 9, the lower number to the higher number, and on this side, the bottom number, B, compared to the upper number, 15, okay? So lower to upper, cross multiply, 6 times 15 equals 9 times B. 6 times 15 is 90, equals 9B, and B is 10. Does it make sense? If that's a 6 to 9, does it make sense 10 to 15? Yes, it does. It makes perfect sense, okay? So we're not looking at the picture representing the numbers so much as just giving us their positions, just telling us how the numbers fit together. All right? Now, let's go on to page 71 and do a problem on page 71 that actually happened in Manhattan, okay? The streets in New York City are pretty cool. They're mostly laid out in nice grids with a lot of rectangles and squares, but occasionally there's a triangle. So in Manhattan, the number avenues, like 5th Avenue, 7th Avenue, are all perpendicular at right angles to the numbered streets, like 45th Street, 42nd Street, okay? And so here's a section of the map. 7th Avenue runs this way, and all these cross streets, okay, all these cross streets would be streets that run into the avenue. Broadway kind of cuts through at a diagonal, though. Broadway's special. So we have some measurements here. They're giving us the measurements of these sections, like how long those blocks are, okay? But we need to figure out a couple more because they want to replace some sidewalks, and they need to know how long the sidewalks are, how long are the blocks. So we need to figure out some of these missing numbers. Okay, they've got the rest of them marked on a map, but they can't read those numbers, so we have to figure them out. We don't have to go back out and measure. We can do it just with math. Okay, so let's set up some proportions. We know this is 280. We know this is 335. So if we compare those, 280 compared to 335, what if we call this X, this piece? Then 280 compared to 335 is the same proportion as 325 compared to X. Okay, and then we can cross multiply, and 280X is equal to those two numbers multiplied together, which is 108,875. I used a calculator. Divide both sides by 280. And X is about 389 feet. Okay, so now we have this number. Nice. Okay, now we need to figure out this one. Let's call it Y. Okay. Well, we can set this up as this length compared to this length. And these two numbers added together are 605. So we can say, well, 605 compared to 315, right? So the bigger piece compared to the smaller piece is going to equal that bigger piece, which is 325 plus 389 added together. And that's 714 compared to the smaller piece, y. Okay, so in each of these cases, we took the bigger piece compared to the smaller piece, and the bigger piece compared to the smaller piece, right? You just have to make sure you're following the same pattern. You can't be like mixing them together. All right, so if you do this, 605y equals 315 times 714, 2, 2, 4, 9, 10. Again, I used a calculator before. And if you divide by 605, y is 372. So that number is 372. Does that make sense? It's a little bit shorter than that. 315 is a little shorter than 335. So all these numbers make sense, okay? So we've got all of our pieces. And then they're going to go on and talk about how long the sidewalks are. But this is the part about side splitting, so that is the part that I wanted to cover for you. Okay, so that is all for the video today. Oh, you know what, guys? Let me do one quick problem. I'm going to make one up for you because I know sometimes you don't like seeing a problem on an exit ticket that you've not seen in a video, so I made up a problem for you. And I haven't even worked it out ahead of time. I'm just going to do it now while we're talking. So sometimes the problems are kind of messy. They've got a bunch of things. So here, look at, we've got a triangle, we've got another triangle. These are parallel, and we're putting a third line in that's parallel, okay? So we've got our nice parallel lines. So look, I only know a couple of pieces of information. I don't know how long this is. I don't know how long this is. Don't get confused. Just look at it one bit at a time, okay? So just look at this triangle first. Don't worry about the other one. Just look at this triangle, okay? So if we just look at this one, we can write a proportion. We can say 3 compared to 6, okay? The upper number compared to the lower number. So 3 compared to 6 has to be the same, this to this, as 2.5 to x, right? All right. Now you can do it a couple ways. We could cross multiply, or you could just use your logic and say, this number is twice as big. The 6 is twice as big as the 3, so this must be twice as big as 2.5, which makes it 5, okay? If you cross multiply, you'll get the same thing. You'll do 3 times x equals 6 times 2.5. 3x equals 15. Divide by 3, and x is 5. Okay? But if you use your logic, you can sometimes do a shortcut. So we know this is 5. All right. Now let's look at the other triangle. Let's look at this one. Okay. What if we just look at that triangle now? Well, look at what we have. We have 2.5 and 5 and something and 4. So again, 2.5 compared to 5 equals something compared to 4. You can use your logic, or you can cross multiply. If you cross multiply, you get 5 times y equals 4 times 2.5, which is 10. 5y equals 10. Divide by 5, divide by 5. And so that is 2. And does that make sense? If this is 2.5 and this is 5, does it make sense that this would be 2 if this is 4? Yes, it does. These are half of those. Okay? So you may see a problem on your exit or in the problem set where you've got a couple triangles happening at the same time. Just focus on one at a time. Okay? Don't get flustered because there's a lot happening. Just start with one thing and then go from there. Okay, guys, that's it for now. Bye.